Okay, we're given this polynomial equation. We're asked to find the degree of the polynomial and to find all of the complex roots. That means all of the real and the imaginary roots, and specify the multiplicity of each of the roots. So first I'm going to start by identifying the degree. The degree in general for a polynomial will be equal to the highest power on the variable. So in this case it's on x. So that implies that the degree of this polynomial is equal to 5. It's a fifth degree polynomial. Okay, let's search for the roots. We're going to do this similar thing as last time. We're going to try to factor this guy. He's x to the 5th minus 6x to the 4th plus 9x cubed, and then 0 on the other side of the equal sign. Okay, the first thing we'll do is check to see if there's any common factors. Indeed, there's a common factor of x. The highest power of x that they have in common is x cubed. So it's x cubed times, let's see, that will leave x squared here, and I can check it real quick. It's because x to the 3 plus 2 equals 5, and then minus 6x here, because x to the 3rd times x to the 1st is x to the 3 plus 1, which is 4, and then just plus a 9 at the end, because x cubed times 9 is 9x cubed. Bring down equal sign, bring down 0. Okay, so now we're going to set each of our factors equal to 0 and solve to find our roots. So here we have x cubed equals 0, and we're going to union that result together with the x squared minus 6x plus 9. But you know, we could actually factor that further. That factors as x minus 3 times x minus 3. In other words, it factors as x minus 3 squared. Set that equal to 0 also. Okay, so we solve each of these. In this case, we're going to get x is equal to 0. We're going to take the cube root of both sides. We get x equal to 0. And this is with multiplicity equal to the power 3. Okay, and that result together with the result we get from this one is, let's see, first we would take plus or minus the square root of both sides, and we would get x minus 3 equals plus or minus the square root of 0. That's just 0. Plus and minus 0 is just 0, so it's just 0. And then we get x equals 3, positive 3. So here's our root for this contribution, and this one comes with multiplicity. Let's check. Up here, the factor had an exponent of 2, so it's multiplicity equal to 2. So the root x equals 3, it counts twice. And the root x equals 0 counts 3 times. That makes a total of 5 roots when we count the multiplicity, and that, indeed, is a degree of our polynomial.